all. This is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic n-queens problem. So this comes under design and analysis of algorithm. So n-queens problem can be solved using backtracking approach. So if we cannot able to find the solution in the state space tree, that is if it is in the depth first search, then you can formulate the solution by going backtracking to the previous node. So this is about backtracking using n-queens problem. So let's first define the definition of n-queens problem. So n-queens problem. So given an n cross n chessboard, we have to place n-queen on some place, that is in an n cross n place, such that no two queens attack each other. So the constraints given for n cross n chessboard n-queens problem is no two queens will be in the same row, will be in the same column, or they will not diagonally attack each other. So these are the constraints of the n-queens problem. So the puzzle was originally proposed in 1848 by the chess player Max Bizzle, and over the years many mathematicians including Gauss have worked on this puzzle, and it is generalized n-queens problem. So the first solution inventor for n-queens solution were provided by Franz Nauck in 1850. Now also extended the puzzle to n-queens problem on an n by n chessboard of arbitrary size. So here are the few questions we will be having in mind. So what is the input of n-queen? So it is a positive integer n. What is its task? So we have to place n-queen on an n by n chessboard so that no two queens attack each other on same row, column or diagonal, or report that it is impossible. So these are its tasks, or these are the implicit constraints in an n by n chessboard. So solving particular problem for different values of n is equal to 1, 2, 3, 4. So let us consider n is equal to 1. For n is equal to 1, it is 1 cross 1 chessboard. We can place the queen on the thing. Since it is only one queen, there is no problem at all. Suppose if we take n is equal to 2. So if n is equal to 2, remember it is 2 cross 2 crossboard with 4 squares. So we cannot place queen 2 in any of the 3 squares possible. So it is impossible to arrive the solution. When n is equal to 3, if n is equal to 3 also, it is 3 cross n. Again here the problem lies, we cannot place queen 3 on any of the squares. So remember, always remember, there is no trivial solution when n is equal to 2 or n is equal to 3. Now let's consider n is equal to 4. So when we consider n is equal to 4, it is a 16 square, that is on a 4 by 4 chessboard. So it is purely a brute force search. A brute force search is nothing but just do it. So when we take 4 cross chessboard, you will have about 16 into 15 into 14, which will give you about 43,680 possible solutions for this problem alone, or for this puzzle alone. Suppose if n is equal to 8, at most one queen per row, which is 8 power 8, which is again will be in millions. So early backtracking also, it will take about 2057 nodes in total, and time to find the first solution is 114 nodes. When n is equal to 12, this will be 12 power 12. So early backtracking itself will take about 856,189 nodes in total. The time to find the first solution will be about, after backtracking, about 262 nodes. So there are different various approaches to the problem can be also found. So brute force is one of the thing, local search algorithm, backtracking, divide and conquer, permutation generation, mathematical solutions, graph theory concepts. So we are going to find the solution using backtracking approach. As I told you, backtracking uses the searching topography. So first let us see we'll place the first queen on the first row. So when we place first queen on the first row, then placing the second queen on the second column or on the first column is impossible, since the queens will be attacking each other. So the possible solution is to place 2 on the third column of the second row. So when we place in this method, then placing queen 3 on first column, second column, third column, fourth column is impossible. So what we have to do is we have to backtrack. So when we backtrack 3, we did not find the solution for 3. So what we are going to do is we are going to backtrack to node 2. So node 2 will be considered to the next column, that is fourth column in second row. So when we place the queen in first column of first row and the queen 2 in the second column or second row of the fourth column, then we might place queen 3 in second column of third row. There is one solution. So far it is good. Now when we are going to try to place queen 4, we don't have any solution. So what we have to do, we have to backtrack 3. So we will backtrack 3 and we will keep it in the position 3, no solution. It cannot be placed in the fourth column also. So again backtrack to node 2. So since we have reached the final settlement of node 2, the queen 2 also, we cannot place any queen there. So what we are going to do is we are going to backtrack to node 1 itself. So when we backtrack to node 1, we can place queen 1 in second row. Then if we place in the second row, queen 2 can be placed in fourth column, queen 3 can be placed in first column, and queen 4 can be placed in third column. So this one will be the one of the solution of an n4 queens problem. So the same way can be applied for 8 queens as well. Thank you.